To anyone watching, I will be proving the Thales theorem, which is basically a theorem about semicircles. So the theorem states that if you have a semicircle with radius r, and you choose a point on the circumference of that semicircle, and what you can do is, if you draw a line from one endpoint to that point on the circumference, and you draw that point on the circumference to the point on the other endpoint of the semicircle, you'll get a right angle here. This is a more basic version of another theorem, which goes as follows. If you have a line with length a and an opposite angle theta, what happens is all the possible places where this top point can be is on the semicircle with radius. The radius will be a over 2 sine theta, and then the height off will be a over 2 tan theta. I mean, this kinda just agrees with what I've just said, but yeah, because a over 2 tan theta, if you do the limit as theta approaches 90, that will just be 0. So we know that the height is 0. Then we know that, for example, the whole length is 2r. Right, so 2r over 2 times sine of 90 equals 2r over 2 equals r. So you know that the radius is just r. So this just kind of agrees with what I've said. I won't be proving this theorem, the proof's a bit more complex, but after I show you the proof of the Thales theorem, I think you could probably have a good attempt at proving it. So let's get on with the proof. Okay, so let's start with drawing a semicircle with radius r, like this. It's probably the best semicircle drawing I've ever done. Okay, so the two endpoint, the graph will be y equals square root of r squared minus x squared. Squared, which means that this endpoint will be negative r0, this endpoint will be r0, and any point here, for example right here, will just be x square root of r squared minus x squared. And then here's a general layout of the proof. Whenever you multiply the slope of two perpendicular lines, you will always get -1. This is a well-known theorem. I can prove it in another video, but the proof's pretty basic, so I won't be doing it here. So what we're going to do is we're going to draw a line from here to here, and draw a line from here to here. We'll multiply the two slopes, and if it ends up being -1, then we'll know that the angle here is 90 degrees, right? So yeah, I'll be doing that. So let's start. To find the slope of this line, to find the slope of any line actually, we do change in y over change in x. Okay, so let's look at the change in y. To go from this point to this point, what we did was the y went from 0 to r squared minus x squared. So the change in y was square root of r squared minus x squared. To go from negative r to x, the x value went up by r plus x. Okay, that's our first line. Now let's do the same thing for our second line. To go from r squared minus x squared to 0, we subtracted r squared minus x squared. So our first point for our second one is negative r squared minus x squared. And now let's look at the change in x. We went from x to r. So our change in x is just r minus x. Now, if there's a right angle here, or if the two lines are perpendicular, then by multiplying these two fractions, I should get -1. Now we will see if by multiplying we get -1. Yeah. So while I'm erasing this is a partially original proof. The original proof which I saw used the property that multiplying two vectors, perpendicular vectors, makes 0. I'm just doing the same thing with slope because slope's easier to explain. So yeah, to multiply these two fractions, first we multiply the two numerators, then we multiply the two denominators and we divide them. So square root of r squared minus x squared times negative square root of r squared minus x squared, that'd just be negative r squared minus x squared. I won't make this x squared minus, I won't like swap these two and get rid of the negative symbol. You'll understand why in a second. Okay, so r plus x times r minus x. We know the really well-known theorem that a plus b, oops, no idea what I just did. A plus b times a minus b equals a squared minus b squared. Keep saying left double click, I have no idea why. So what we know is that since a is just r and then b is just x, we just get r squared minus x squared. And this is what happens when we multiply these two together. And now the rest is obvious. Cancel out. -1 over 1 equals -1. I was right. Yay. So the lines are perpendicular. Yeah. So that's what the theorem is. I'll go back to the theorem. So one last recap of the theorem. So the theorem states that if you have a semicircle, okay, let's say this be the midpoint, and you choose a point, by connecting the two endpoints to that individual point, you will get a 90-degree angle here. I just proved that. Yeah, it's a cool little theorem. Now, here's a challenge if you wanna just do some of your own maths. Now, make this angle something other than 90, maybe 30. And then think, okay, so if we let this side be A, then we let an angle be 30. Like 30 degrees or an angle theta. You can think, what points can there be for this point, for example, capital A, to work? So maybe you can try setting up an equation. There are so many possibilities. You can have fun and try. I might make a second video, I don't know. I probably will, showing how you can do the a over 2 sine theta and a over 2 tan theta thing which I spoke about at the start. Have fun. I'm using this theorem, you probably already knew about it, but yeah, bye.